Hello, welcome back to Java for Beginners series. This is video number 2 and a two-part series to introduce variables. In this video, we're going to talk about primitive data types. So join me.
Primitive data types are the foundation, the building blocks of anything that Java stores in memory, okay? So anything that Java stores in memory, meaning any data that your application deals with, processes, etc. So we're gonna learn all about the 8 primitive data types, which are split in 4 categories. All right, so we got 4 categories for primitive data types. We've got the whole numbers, so 1, 2, 3, 5, 10. There's no dot, there's no 1.2, there's no floating point. Then floating point numbers, so anything that would have a dot. It doesn't have to be 1.2, it can be 1.0. As in like a whole number, but representation in memory would be a floating point number. And we're going to see that in a bit. Characters, so A, B, C, D, etc. You get the point. And booleans, these are either true or false. Let's begin talking about the first category, the integer or the whole number. So we've got 4 types, primitive types within that category. We've byte, short, int, and long. Now they all differ in terms of how much memory is allocated for each type. So this one has 8 bits, this one has 16 bits, 32, 64. So what is a bit? When we say like 16 bits, what does that mean? A bit is the smallest unit of storage or data in a computer. It can only have 2 values, either 1 or 0. If you think of it as like a light bulb switch, it's either on or off. And that's how computers actually work. They aggregate and manipulate those signals that can either be on or off and store them. And that's how every number and everything, pictures, videos, everything you do on a computer is represented in those bits, basically either 0 or 1. So going back to the previous slide, we see that we have different sizes for different types. Why is that? Well, you see, memory is a finite resource. Say you have a laptop with 8 gigs of memory or 16 gigs of memory. So you want to be very careful with how you're using that memory as a software developer. For instance, when you're on Google Chrome, which is notoriously known for consuming so much RAM or memory, if you have something like 100 tabs open, then your computer will start to slow down. And the reason why primarily is because Chrome is using too much memory that your computer is almost maxed out on its available memory. And so as a software developer, you always try to use the least amount of memory possible in your program. So if I want to define a variable that I know the values for that variable will range from minus 128 to 127, then that's the type that I should use, byte. For like a whole number variable. If I know that the number will be higher than that range or lower, then I'll go with a short. If not, I'll go with an int. If not, I'll go with a long. You get it? Now, the bigger the number is, the more bits you're going to have to need to represent it, as in the bigger the size in memory that or RAM that you're going to need to fit that number in. So I'm going to show you a website where we can actually have a look. It's like a calculator for like if you input a number in this form, which is called the decimal form, it will transform it into binary form, as in it will be transformed to what the computer will actually store when you define a variable. So you say you define a variable with value 10, then we're gonna see how that looks like in the binary format as bits. All right, so I've just typed in Google decimal to binary calculator, and I'm just gonna go with the first one, and I'll just put the number 10, and I hit convert, and I get the binary representation for that. Now, if you wanna understand how that conversion happens, it's probably a little bit outside of the scope of this course, but nonetheless, just to give you an idea, if I have 127, convert, that's how many digits? 1, 2, 3, 4, 5, 6, 7 digits. Now going back to the slides, we see that we needed 8 bits to represent 127. Why is that? Well, you see, we need 1 extra bit to represent the sign. So from 127 to minus 128, there is also 0 in the middle. That's why it's not from 128 to minus 128, you see, because 0 is counted off the positive side. So we don't have 128 here. But the point is, we need 7 bits to represent the number from 0 to 127, and the last bit is for the sign. So let's take a look at some examples here. So the types that we have are byte, short, int, and long. So let's start with byte. Byte is a keyword, just like int, and you use it, you give them a name. So I'm going to give my byte as a name, and I'm going to say it is equal to 1. And I'll print my byte and see what's going to happen. We get 1 printed. What about 127? Let's run that. We get 127. So what if I want to give it a value that is outside the range? So 128. What's going to happen? I get an error saying that I've provided a value of int to byte. Remember how we said the Java is a strongly typed language, which means that you have to provide a value that is compatible with the type that you're defining. So to fix that, I can change this type to int, and then I'm going to hit run, see what's going to happen. I get 128 printed, no problem. What if I change it to short? Will that still work? The answer is yes, because short has a higher range than byte. So basically 128 is contained within 32,767. So I can define either short, int, or long for a number that is 128, but I cannot contain it within a byte. Just 8 bits is not enough. You would want to go with short if you're sure that your number is not going to exceed this range. All right, let's move on to something called casting. So I have integer and byte, right? And if I hit run, I can print both, nothing special. Okay, now what happens if inside an integer a, I want to store the value of byte? So a equals b, okay? If I hit run, I get the value of b printed twice. Why? Because I took b, stored it in a, so now a has 127, b has 127, and I'm printing both 127s. Make sense? Now, what if I want to do the opposite? So I'm trying to store the value of a, which is an integer, in b, which is a byte. So the integer is 32-bit. The byte is only 8-bit. So you're not going to be able to fit 32 into 8. So you can perform something called casting, which is to just say between parentheses byte. Now that's going to take your 32-bit and it's going to trim it and take only 8 bytes of it and then store it in B. The value is not going to be what you expect. Let's hit run and find out. We got -6 for B. Why is that? So it has to do with the way numbers are stored in memory. We're not going to get into it because this is a little bit too advanced for beginners. Just know that you're not really supposed to do this. Like, it exists as a functionality, but really you don't want to do that. Like, you don't want to go from a big storage to smaller storage unless you know what you're doing. But going from a smaller storage to a bigger storage, 8 bits to 32 bits, that's totally fine. Going from 32 to 8 bits, you're not really sure what's going to happen. Now we've seen byte, short, int. Let's talk about long. Long is very similar to all of them, with one exception. So when you're initializing a long variable, so long, my long equals 9, let's say, and I'm going to print my long. See, the way Java is designed is when you have a literal number that you're assigning to a variable, this literal number is presumed to be an int value. So it's presumed to be up to 32-bit long. So if I start adding numbers here, I'm going to run into an issue that if I add one more number, it's complaining. What is it saying? Integer number too long. Okay, let's have a look and see how many digits are there in this number that we're trying to assign to the long. So I'm going to copy this. I'm going to go back to our calculator, paste, and convert. So how many digits we have? 34 digits. Okay, let's go back to the slide. So 34 digits is above integer. So I understand if we couldn't assign that number to an integer storage, but why are we not able to assign it to a long? See, the problem we're facing here is this literal number. So this is called a literal number. It is always presumed to be an integer unless you specify otherwise. And how do you do that? Well, you tell it this is a long by adding a capital L at the end. And now I can make it bigger, and then if I hit run, the number will get printed with no problems. All right, now let's continue to the second category, which is the floating point types. And we have two of them. We have the float and the double. Now the float has 32 bits, the double has 64 bits. So the double is actually double the float, and hence the name. So the way it works here, so unlike the, say, integer and long, you could have a reliable representation of every number within a range from this number to this number. Here, the representation isn't the numbers aren't very reliable. They're approximated. So let me show you how with an example. But before we do that, remember that here we have 7 decimal digits of approximation, where here we have almost double that, 15 decimal digits of precision. So take a look at this example here. I have a float that I'm calling value, and I'm giving it a floating point number. And notice that I end it with F, because turns out by default, if you don't, then it's considered to be, you guessed it, a double. So just like in whole numbers, everything is considered by default to be integer. So if you want to assign it to a long, you need to specify, well, this is a long. Here it's the other way around. Here, all these floating point numbers are presumed to be the bigger size, which is the double. So you want to be specific and say this is a float. But that's besides the point that I'm trying to make now, which is if you hit run, notice that the number here is different to the actual number being printed. So let's count. 1, 2, 3, 4, 5, 6, 7. Sounds familiar? It is the 7-digit precision that we were talking about in the slides. I can maybe do a few numbers here and then hit run, and notice what's going to happen. You see what's happening here? It is prioritizing the decimal part to represent, and then it ran out of digits. So this part here is now a 0. So it is not really an accurate procedure. So if you want to have a number like this, which is a lot bigger than what a float can handle, then you want to get rid of the F here, and maybe you want to go with a double data type. And if you hit run, you see that your number is better represented. It's not the whole number though. Like 185315412, 1541, and then this one was rounded to 2. Okay, so keep that in mind. It is never accurate, and there are ways to obtain accurate measurements for floating point numbers. They're just not done using the primitive data types. They are done using other data types that we may visit in the future. But for now, just know that it's like once you hit the limits of what these data types, primitive data types or floating point can store, then you're going to run into some inaccuracy, which is expected and should be understood by every developer when working with primitive type floating point data types. All right, let's talk about casting for float and double. So I'm going to create a variable here called double1 equals 1.0. And like I said, this is automatically considered as double, but you can add D at the end. It's up to you. And if you want to define another double, here's something we didn't talk about before. You can just, before the semicolon, add a comma and then define double2. So basically in one statement, you're performing 4 operations: the declaration of double1, declaration of double2, the assigning of 1.0D to double 1, and then 1.0 to double 2 as well. And let's make it this one too. Right, I'm gonna make a float here, and I'm going to try and store double 1 inside float. And as we've discussed before, to solve that issue, you cast to float, and then you're able to downgrade that value from a double to float. I'll hit run. Oh, I need to add a print statement to float 1. Oops. And then I hit run and I get 2.0. I want to show you something that is not probably what you would anticipate, but say I perform s out double 1, which is 2.0, minus double 2, and see what's going to happen. So instead of getting instead of getting 0.9, we're getting 0.8999999, etc. If you're a little bit more curious and you want to know what's going on, you can go ahead and read about the IEEE 754 standard that the Java language implements. See, this number over here wouldn't be precisely stored as 1.1. So when you're performing these mathematical operations, you know, things are not going to work out as precise as you would like it to be. So let's just leave it at that for now. As beginners, that's all you need to know. So for our third category, we're going to talk about characters. Characters category has a single primitive type called char or char. And as the name suggests, it is used to store a single letter, digit, or symbol. And the way it does that is very simple. You would have a table with numbers that are assigned to characters. So, you know, you remember the whole conversation around everything is binary, so everything has to be represented in binary, whether it's like text, numbers, photos, videos, etc. So the way you would actually store and represent those letters like A or B or C is to assign them to a number. So the character has 16 bits, so it can store any positive number from 0 to 65,000. And let me show you that table. It's called Unicode. All right, so let's have a look here. I've got a Wikipedia page for the Unicode characters. And, you know, I'm going to scroll down to there's a bunch of tables basically, but I'm going to scroll down to the basic Latin. And then you see all these symbols that you're familiar with, the parentheses, the $sign, the hashtag sign, the double quotation, etc. And then the numbers, and then all these letters, they're all assigned to a number, which is here. The decimal representation of that number is here, and the code for it is here. And so we're going to be using these three columns to assign the three ways to initialize and assign a value to a character that we're going to see now. So I'm going to make this a little bit smaller, try to fit both of them together. Hopefully we can. Right. So how do you define a character? You go char A, let's give it a name A, or actually my character, equals. The first method is to use a literal character. So A, and then if you s out my character and hit run, you get A. So what is A's decimal representation in the table? Like lowercase a. So if you scroll down, these are all uppercase. And then if you find the lowercase representation, it's 97. So I can just remove that and put in 97. And if I hit enter, I get the same result. Sorry. I could also use these four digit number here. It's not exactly a number. It's like it contains letters as well. So it's a hexadecimal representation, which is another counting system. So we have the decimal, the binary, and this is a hexadecimal. But what you need to know for now is you could also assign a value using this thing here by having single quotations / U for Unicode, and then you paste that number. And if you hit enter or run, you get A printed. And so you can do this for any value here. So for instance, this one here, I can take this one and I can have that number over here. And if I hit run, I'll get that value that is over here. Let's take another one. For instance, this one with an accent. It's an E with an accent on it. I can either paste it, I can either put the number this way and get it, or I can copy that and put it between single quotes and get it. Or like we did before, \u. And so this is how you define a character in a primitive character in the Java language. For the last category we have within our primitive data types is the Boolean category, which has one type, which is the Boolean type, and its size is 1 bit, and it can either be 0 or 1, true or false, yes or no, on or off. You get the point. And there's really nothing to it. So let me show you. I mean, this is how you define it. I'll show you the example in the code. And it's usually used for logical decisions, something that we'll get to later down the line in the course. So defining a Boolean is just type in Boolean, my bool stands for Boolean, true, and then you can S that out and you see true. You can change that to false and print that and you get false. There's really nothing to it more than this. Congratulations, you've just learned all about the primitive data types in the Java language. And remember that these data types are the building blocks for anything that is being stored in memory by any Java program. So keep that in mind, and you've learned all about them. So congratulations. Here's the last example for basically each type that we've learned. So just have a look and feel free to experiment on your own machine with these data types.
Thank you for watching the video. I hope you found it useful. In the next video, we're going to introduce and talk about operators. Thank you, and I will see you in the next video. Bye-bye.